9.7 Solving linear inequalities in one variable. Alrighty, let's see our objectives here. Graph intervals of real numbers, solve linear inequalities in that form, and we're going to solve some different forms and some linear equations here. So remember, the symbol for infinity is that kind of like sideways laying down 8, or you've also got negative infinity. Okay, remember, it's not a number. Okay, be something I explain more in class, but when you're little, you start thinking of infinity as a number. It's really not, okay? It does have direction, but really we don't think of it as like a number. Be kind of not really responsible to think of it that way. So let's go to our first one here. Graph the open interval from 3 to positive infinity. Well, we know that positive infinity is going off to the right-hand side here. So let's draw us a little number line here. Okay, draw a little number line here. And I'll go ahead and put 0 right here, and then I've got 1, 2, 3, 4, 5, and then dot, 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 and then of course we got negative 1. Well, notice this is going off into the right-hand section, so that's going to be a positive infinity. And then we got 3. That means that this number right here is going to start at 3, okay, but not include 3. So how you're going to want to do that is, notice how this is here. Okay, you kind of look at that, let that be your idea of how to do this, and then you can graph this going in that direction, and notice it's going in the infinity direction. So that's how you graph that one. And then this would be the interval notation, because in Hawks, whenever you do this, you would actually kind of pull that over there, because you can never equal the end of infinity. So that's how come the interval notation for this would be something of that form. Okay, graph the half open interval at, okay, now this is one of those you want to read from the middle. Okay, so notice it's saying x is greater than 0, but x is less than or equal to 4. Okay, reading from the middle and being intentional, let's read this. So graph our number line here. Okay, and we'll just go ahead and just show this is 0, 1, 2, 3, 4. Okay. X is greater than, notice it does not have an equal sign there. So greater than, well, that's going to be just our parenthesis, okay? So that would be like our open parenthesis right there, okay? Well, open parenthesis is going to be this right here, because we know, and we notice it's greater than, so it's going off to the right. Well, here, we also have less than or equal to, so that's going to be like a closed, okay? We have closed, those are always done by brackets. So our opens are always going to be the parentheses, and our closed are going to be brackets. Well, notice it's saying less than or equal to, so we can have the brackets be the bracket here. And so x can be any one of these numbers inside there. X can be any number except 0, but it can get infinitely close to 0, but it can go all the way up to, okay, 4, and include 4. And that's how we would do that one. Represent the following graph using algebraic notation to state what kind of interval it is. Okay. Okay, looking at this, notice that we have a bracket here. That means we can include 1. Well, include what? Well, thinking in terms of x, we'll just go ahead and kind of keep it that way. Well, what can x be? Well, looking at it, x can be what? Well, notice it's going in the positive infinity direction. Well, that means x can be a greater than, okay? Notice the bracket, or equal to, well, what can it include? 1, okay? That is what kind of interval we have, okay? Well, and then the kind of interval that they want us to put down is that we have a half open interval. Okay, let's continue on. And we have represent the following graph using interval notation and state what kind of interval it is. Okay, well, we have the graph of -3 to -1. Okay, so let's look at this. -3 to -1. Looking at this, notice I have parentheses, okay, which means, and as I've tried to tell you in classes, the graph tells you how your interval should look. So if I decide to go ahead and copy this, notice my graph is saying I've got this here, this here. So that means I can have, let me get it in black here, I know my interval is going to have this. Well, that's saying that I can get infinitely close to 3 and I can get infinitely close to 1. Okay, that means x can be anything inside this realm here, but not including -3 and -1. Okay, and then whenever we go over here, this is called an open interval. Sure I wrote that correctly. Okay, let's continue on. Any principle or rule stated for inequalities with the less than symbol hold true for any of the others. Okay, so just kind of as a rule, you'll see what it would mean. Okay, if A and B are algebraic expressions, okay, just expressions, and C is a real number, then the inequalities are going to look like this. Okay, notice it's the same rule we had whenever there was an equal sign. What I do to one side, I have to do to another side. So let's come here to example 5, and I'll show you exactly what we mean by this. Okay, looking at example 5, we have solved the inequality of y minus 3.2 is greater than or equal to 5.6, and graph the solution set. Okay, and then we'll write the solution set using interval notation. So let's come down here and rewrite this as y minus 3.2 is greater than or equal to 5.6. Well, I'm going to come in here and go ahead and add 3.2 to both sides. Okay, and I'm going to get y can be greater than or equal to, well, we got 8.8. Okay, well, y can be greater than or equal to 8.8. Let's go and put that on the graph first. Come in here, draw a graph. How am I going to start? I'll go and start at 0. So I've got -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll put 9 there, 8 there. 8.8 is going to be roughly, we'll say right inside. We'll say right there. Okay, so that's going to be my 8.8. Well, it says y is greater than or equal to. The moment you see equal to, that's going to be closed, which means you're going to have brackets. Okay, well, brackets where? Greater than. So that means I need a bracket going that direction. Where is it going to go? In the positive infinity direction. So it's going to look like that. And remember, infinity we can never equal to, so we're going to have to close that off like that. And notice that once you graph it, okay, you have your interval notation. You can do this, put down your parenthesis, your closing parenthesis, put down your 8.8, your comma, and then your infinity going in the positive direction. And it's literally just as simple as that. Like I said, on Hawks you can't do this, but in what I suggest doing is, even on your scratch paper, do it as a try to do your graph first, and that's going to tell you what your interval notation should look like. Okay, let's come down here. Let's look at this. Okay, multiplication principle for solving linear inequalities. Notice it's the same thing as whenever there was an equal sign there. These work exactly the same way. Some things are going to change up shortly, but especially if you're like dividing or multiplying by a negative, that's going to be something we're going to need to get into. Okay, there it is right there. In other words, if both sides are multiplied by a negative number, then the sense of the inequality is reversed. Basically, if you decide to if you have to divide by a negative, you have to reverse your signs. We're going to do that. We're going to do that as some of the examples. So let's look at this one first. Let me rewrite this as, okay, we've got 5x is greater than 15. Well, if that was an equal sign, you know exactly what to do. Same rules here. Divide off the 5, and you're going to get x is greater than 3. Okay, notice there is not an equal sign in there, so this is going to be an open. Okay, and if you decide to graph this, you come in here and go, okay, well, I've got 0, 1, 2, 3, 4. Well, x is greater than, that's going to be a parenthesis going in the positive direction because it's saying greater than. So there's a positive infinity there. Remember, you don't have to put the positive. Infinities, we always have to keep as a parenthesis when we close it off. So there's my interval notation of 3, infinity. And it's just straightforward and simple like that. You don't have to make it harder. Okay? Now let's show them what they're talking about the negative. I just kind of kept this one and wrote down. Notice solve the inequality for negative 3x is less than or equal to 12.3. Well, they come in here, do the whole process like we've talked about, but notice once we get to right here, okay, we start to do the process of dividing by a negative, and I don't know why they have that 3 there, and the moment you start dividing by this negative, you have to flip the sign, okay? That's just going to be something you're going to have to remember. We're going to talk about it in class a lot. I'll ask you, what do we do? What do we do? So, you got to remember, flip the signs when dividing or multiplying by a negative. So, here we are, solving linear inequalities, and then multiplication or division, and like I said, these are just some things I left in here for you for the very end. Let's do some Hawks examples, and that'll be come a lot more clear.